Hello everyone. Today I am going to discuss one problem from CSES problem set which is required substring, and along with this problem I will discuss one string algorithm. Okay. Uh, if you find this series helpful where I am solving CSES string algorithm section and along with that explaining other string important string algorithms, you can like the video, subscribe to the channel, and also share the playlist among your peers. So let's start with the problem. So what is the problem? So we are given a string of length m. Okay, now we have to find the number of strings of length n having a given pattern of that string. Okay, so let's take one example. Let's say we have some string given ab. Okay, now we have to find all the strings of length 3, all the strings of length 3 which has ab as a pattern, as a substring. Okay, so what could be the possibilities? We can take AAB as a one string which has AB as substring. Similarly, we can take BAB. BAB also has AB as a substring. Similarly, we can take ZAB also. Okay, ZAB will have AB as a substring. Okay, now there are total 26 combinations here. Okay, now another possibility is that we take AB as prefix. Here we are taking AB as suffix, but here we will take AB as prefix. Okay, now if we take ABA, so ABA has AB as substring. Similarly, ABB has AB as substring. Similarly, ABZ has AB as substring. So total number of possibilities here will be 26 here and 26 here. So overall possibilities will be 52. Okay, so we have to print 52. Now you might think that let's say we have some aim. Let's say length of the string is aim. So let's say aim is 2 and n is 2, n is 3. Okay, so we have only one place left. So we can either place 26 character at the start of the string, or we can place 26 character at the end of the string. But that is not the case. So you might think that m 26 to the power m minus n into some other thing. That will not help, because let's take one other example. Let's say we have something like a. Okay, now AA, here if we take A as a prefix, okay, if we take AA as a prefix, we'll get AAA as a string. Similarly, AAA as AA as prefix. Similarly, if we take A again as a suffix, here AAA as AA as suffix. So what does it mean? That when we are considering prefix, we will get one AA, and when we are considering suffix, we will get another AAA. Okay, so that's why this approach will not help us, because we'll count something twice. Okay, now let's look at the other parts of the problem. What are the constants? So we have to print the number of strings. We have to print the number of the strings, not all the strings. Okay, modulo some value. Okay, now what are the constants? Constants on n is 1000 and constants on m is 100. So what we can say, that order of nm is definitely possible. Order of nm is definitely possible. Also, here it is a string problem or character problem. So we have to also consider the size of the alphabet. So order of n m into 26 is also possible, and I think order of n m squared should also be possible, because it is around 10 to the power 7. So how we are going to solve this problem? Okay, that is one important thing. We will solve this problem in order of n into m into 26. So how we are going to solve this problem? Okay, now we'll solve this problem using recursion. Okay, recursion. So what are the state? What are the variables of a particular recursion state? The first variable will be always the current index. Okay, current index I, and another variable j is that uh, till what we are currently matched with the given string s. Okay, these are the two parameters. So I'll explain now. Okay, I means I could be from 0 to n. So I could be from 0 less than equals to I less than n, and j could be from 0 to m. Okay, 0 less than equals to j less than m. Okay, now if I equals to 1, I equals to 1 and j equals to 1 means that we have already taken one character, zeroth character, and that matched with the first character, zeroth character of s. Okay, now I equals to 2 and j equals to 1 means I equals to 2 and j equals to 1 means that we have taken zeroth index and first index, but the is 1. So let's say that our new string is p. Okay, so we can say that p1 equals to is 0. Okay, Now let's take another value. Let's take we have I equals to 4 and j equals to 2. J equals to 2 means that we have already matched the prefix of length 2 from h. So we can say that p from 3 to 2 to 3. Okay, p from 2 to 3 is matching with if we use zero based indexing. P from 2 to 3 is matching with is from 0 to 1. Okay, that's what I and j means. Okay, now we have to make transitions from I comma j. We have to make transitions from I comma j. How we are going to make transitions from I comma j? We are going to make transitions from I comma j. So we will try to take every character from j, character. Let's say character equals to from A to Z. We will try to take every character. Okay. If we take A, we'll check that how the value of j is changing. If we take B, how the value of j is changing, and similarly for till z, how the value of j is changing. So from I plus 1, so from I plus 1 we can go to a new j. Okay, depending on the value of ch. Okay, depending on the value of ch. Now we could have some brute force algorithm where we are determining the what is the value of n. So what we can do, we can start the matching. Okay, let me take one moment to get some appropriate example. So what I was saying that there would be some brute force algorithm, but the brute force algorithm will not help us because currently we have only two variables. One is what is the current index and what is the length of the prefix we have matched. We don't have the string we have already created. Let's say we don't have the string p which we have already created. If we have the string p, that would be the brute force solution. If we have the string p, then we can compare some suffix of p with the prefix of s. Okay, that would be the brute force solution. But according to our current recursion state, we will only have the string I and j. Okay, string I and j, where I have already told I is the index in p and j is the index. Sorry, I is the index in p and j is the index in s. Right. Now we have to use something to determine the nj. Okay, if we determine nj for each character, then our recursion value will be recursion of I comma j will be nothing but recursion of I comma j will be nothing but recursion of I comma j plus recursion of I plus 1 comma new j, depending on the correct character. So we'll iterate over each character and we'll try to determine the value of nj, and we'll do recursion of I comma j plus equals to recursion of I plus 1 comma nj. Now, before jumping on to how we can determine nj, let's thought about the base case. Okay, the base case of the recursion. Base case of the recursion will come when I will be equals to n. Okay, now I will be equals to n, and how we can say that the given string has s as substring, the given string p has s as substring. We can say if the j is equals to m. So if the base case is that if I equals to n, we'll just return the value of j equals to m. Okay, if j equals to m, we'll return 1. Otherwise, we'll return 0. Okay. Now we'll jump into how we are determining the value of nj. So for that, we have to understand one algorithm which is called KMP, 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 or we can say that LPS. What does LPS mean? Let me write it here. LPS, LPS of I. Okay, let me increase the font size. So let's do 25. Got hang on one. Okay. So what does LPS of I mean? LPS of I means that what longest prefix which is a suffix ending at index I. So let me take one example to for you to understand it better. Okay, let's take one example. Mm, let's take one example. Let's jump let's jump to the KMP section for CP algorithm. So you are given a string S. The prefix function of the string is defined as an array pi or LP, as you can say. Where pi I is the length of the longest proper prefix of the substring 0 to I, which is also a suffix. Okay, so the prefix which is also a suffix of a string substring 0 to I. So let's take this example ABC ABCD. Okay, let's take this example ABC ABCD. Okay, now we'll compute the value of pi I or LPSI for every index. So here, let's say we are considering the substring from 0 to 1. Okay, this substring. Here, what is the length of the prefix, which is as well as suffix, that will be 0. Similarly, for ABC, the length of the prefix, which is also a suffix, is also 0. But here, if we consider ABCA, here you can see that A is a suffix as well as a prefix. Okay, that's why we can say that LPS of 3 is 1. LPS of 0 is always 0. Okay, now here we consider the length of this substring of length 5. Here you can see that this AB is matching with this AB. So we can say that LPS of 4 is 2. Similarly, if we take this, the length of substring 6, prefix of substring 6, here ABC is matching with ABC. So LPS of 5 is 3. Here if we take ABCD, the entire string, it does not have any prefix which is also a suffix. So the value of this will be 0. So our LPS or pi array is 0001230. So 0001230. Now the the brute force algorithm of counting the pi value or LPS value is order of NQ. So you can, I will give the link of the article in the description box. You can check the brute force algorithm out. How is brute force happening here? So we are checking for every value of k, if the substring the prefix of 0 to k is same as the suffix, then we are doing pi of I equals to k. So we are just for every substring we are checking for every possible prefix value. Okay, so this is order of NQ solution. Now we have something better. The problem could be solvable in order of n. The problem is solvable in order of n. Okay, order of n, because we have some already pre-computed values. Okay, so let me take some moment to gather some examples. So let's take one example, which is AAA, AAA, AAB. Okay, AAB. Now for computing this is matching with this prefix, so we can say this is 1. And similarly, we'll take two values, right? One is I and another one is, and one is I, which will point to the current character we are comparing, and another one is j, the current length of the prefix we are comparing. Okay, so initially I will be pointed to 1 and j will be pointed to 0. Now we'll check if s of I is equals to s of j, we'll move the pointer forward. Okay, we'll move the pointer both I and j forward. So s of I is matching with s of j, so we'll increase the value of j, assign the current value of j to LPS of I, and we'll move the both I and j pointer forward. Okay, so LPS of 1 will be 1, and we'll move the I pointer forward and j pointer forward. Similarly, here also I and j are matching, so we'll increment the value of I by 1 and j by 1, and assign LPS of 2 as 2. Okay, LPS of 2 as j. This is also matching, so we'll assign 3 here. Now this is also matching, so we'll increment the value of I by 1 and j by 1. Okay, so this is also matching, so this will be 4, this will be 5, but here these are not matching, so the value will be here the value will be 0. So the final LPS array will be 0, 1, 2, 3, 4, 5. So let's jump into the algorithm, we'll understand it better. Now after that there are some optimizations also. Okay, now let's jump into the code. So this is compute LPS. Now we are initializing I with 1 and j with 0. Now if the SI value and SJ value are matching, then we can say that this prefix is matching with the suffix ending at the ith index. So we are incrementing the value of j, assigning LPS I as j, and we are incrementing the value of I. Now here, otherwise, if the value of j is 0, then we will assign LPS of j as 0. Okay, LPS of j as 0. Now, another important case comes where we can say that LPS of j is not 0. Okay, LPS of j is not 0. So let's take one example. Here, the example is AAB, AAB. Okay, so this is a slight modification of the above given example, which is AAB, AAB, and AAAB. Okay, AAAB. Now, here we will assign 0 to this. Now we'll compare s of I and s of j, so these are matching, so we'll assign 1 to here. Now s of I will be this and s of j will be this, these are not matching, so we'll assign 0 to this, and j is set to 0 now. Okay, Now we'll match it, zero this with this, so these are matching, so this will be 1. Now after that we'll compare s of I and s of j, these are matching, so we'll increment the value of this to 2. Now after that we'll try to compare this one and this one, right? This one and this one, right? What we will try to do is that we are comparing this A and this B, but these are not matching. So you might think that we'll assign the value of LPS of J to 0. That is possible, but we have some better approach. Okay, so but the LPS value of this is 0, 2, right? So 2, right? That means that this suffix is matching with this prefix, right? This suffix is matching with this prefix. So instead of instead of setting the LPS of I value to 0, what we can say is that this value is matching. So we can say that there is a suffix ending at this index, which is also a prefix of length 1. So instead of setting LPS of I to 0, we can set LPS of I to LPS of j minus 1. So we can set LPS of I to 1. Okay, LPS of I to 1. Similarly, this will be set to 2. Okay, so here you can see that yeah, I think I have mistaken something. 0 1 2 AAB. Okay, piece of I. How they are setting this as 2? Piece of I is piece of j minus 1. Let me take some time. So we'll set the instead of setting LPS of I to j, what will we do? We'll set j to LPS of j minus LPS of j minus 1. Okay, j to LPS of j minus 1. So we'll set this, the value of LPS of I will be at minimum LPS of j minus 1. Okay, so after setting this j to LPS of j minus 1, we'll try to again check this value of I to LPS of j, this value of j. Okay, now these are matching, so we will increment the value of both I and j. Okay, so this will be 2, and again the value of I will be incremented to this b, and the value of this j will be incremented to this b. So now these two are matching, so I will increment the value of I and j both. So the value will be 0 1 0 1 2 2 3. I hope you get it. If you have any doubt in this part, you can rewatch the video, or you can read the KMP algorithm. These are explained quite in detail in this article. So please go through this article and also rewatch the video, or you can also rewatch any other YouTube videos. But the main algorithm is that we are computing the LPS array longest prefix, which is also as suffix in order of n. So after computing this LPS array, how we are going to use this for our current algorithm? Okay. So our current algorithm here is that we are trying to find the value of in j. Okay, we are trying to find the value of in j from the previous value of j. Okay, we'll use the same algorithm here. So let's jump into the code and understand it better. So here in the recursion step, this part is for computing the LPS array. Okay, this is just copied from this algorithm. So this is nothing special. So you can check that out. Now here the most important part is the recursion part. Okay, in the recursion we are taking two parameters. One is I, the index in the string p, the newly found string p, and j is the index in the string s. Okay, now if I equals to n, the base is, I have already explained, I equals to n means that we'll return 1 only if j is equals to n. Now this part is for memorization. So we'll use recursion along with memorization to make the time complexity order of n into m into the computation we are doing in part step. Okay, so here we are initializing the value of answer with 0. Now we are going for each and every character, and we are trying to put this character ch in the p of I plus 1. So we are trying to put the j character in p of I plus 1. Now we are setting the new j value as j. Okay. Now if j is less than m, if j is equals to m, then we don't have to care anything, because we have already found the substring of s in the given string p. Okay, in the newly constructed string p. So that's why we don't care. If j is equals to m, we don't care. about anything. Okay. Otherwise, we will try to change the value of j to something in j. Okay. Now we'll use the same algorithm we were using in the prefix function. Okay. So we were setting that if si equals to sj, we are incrementing the value of both j and I and setting the value of LPS of I to j. Now otherwise, if si equals to or not equals to sj, and if j equals to 0, then we can't change the value of j to some LPS of j minus 1, right? So that's why we're incrementing the value of I. Otherwise, we are setting j as LPS of j minus 1 because uh, these values are matching. Because the length of this is 1, so the minimum value of LPS of I will be 1. So that's why we are setting new j value of LPS of j minus 1 until s of nj minus a is not equal to ch. Okay. So after this is done, we have set nj as LPS of nj minus 1, nj minus 1. If s of nj minus a equals to ch, so here it is done, right? So we have set j to LPS of j minus 1, right? We have set j to LPS of j minus 1. Now, if this character and this character matches, this character and this character matches, we'll do j equals to LPS of j minus 1. Sorry, we'll increment the value of LPS I by 1. That's why we are incrementing the value of nj plus plus. We are incrementing the value of nj. And after that, we are doing answer equals to recursion of uh, I answer plus recursion of I plus 1 comma nj. Okay, I hope you get it. The overall time complexity of this recursion is we have two parameters I and j. So I could go to at max n and j could go to at max m. So order of n into m, and at each step we are doing 26 characters. We are checking with 26 characters. So that overall time complexity will be order of n into m. This part, the for KMP, this is linear. Amortized time complexity of the entire KMP is linear. So we can say that the overall time complexity is nothing but order of n into m into 26. So overall time complexity is order of n m 26. Okay. I hope you get it. Please read the article of prefix function KMP. I will provide the link of this article in the description box. I will provide the link of the code also in the description box. If you have any doubt in any part of the code or explanation, you can always ask in the comment section. This is quite an interesting problem. So I will suggest you to try this other CSES problem, substring algorithm section. I will try to explain each and every problem here. If you find this series helpful, please share it among your peers and also subscribe to the channel. Thank you.